so we're talking about angles of elevation and depression. In a previous problem, we talked about let's get a color here. We talked about a treadmill that was raised up so much so that we'd have a 7-degree incline for our walking surface. And you remember that was called the angle of elevation, okay? Elevation. How far up do we raise it? Elevation. We can also talk about the angle of depression. Let's say you're flying in an airplane and there's a what they call them, landing strip down there, an airport. We're flying along and we're going to go down to the airport. We got to know how far depressing we're going to go. You know, like what's our angle of depression? We could fly flat or straight, or, you know, parallel to the ground. But if we want to start going down, that's going to be an angle of depression. Now look at this picture here because it's really cool. When you've got your ground level in a sense, and you've got this up here, you can see how that this angle is congruent to this angle. When you cut those two parallel lines with this transversal, those alternate interior angles are congruent. So there's a connection between the angle of elevation and the angle of depression. And then we're going to use that to kind of help us set up some of these problems. It's going to be easier for us to work with it, knowing that in that way. Here's a real neat problem from the book. It says Leah is meeting friends at the castle in the center of an amusement park. I don't know if you've ever been to a park with a castle or not, but I have. She sights the top of the castle at an angle of elevation of 38 degrees. So you can see she's standing here. She's looking at the castle tower. She's looking up at an angle of 38 degrees. Her angle of elevation is 38 degrees. It says, from the park's brochure, she knows that the castle is 190 feet tall. You know, they want you to know how tall their castle is. If Leah is 5.5 feet tall, about how far is she from the castle to the nearest foot? Make a sketch. Well, they've made the sketch for us. And so I'm just going to pull this down a little bit. They've made the sketch for us. So basically, got this castle, got this tower. That's 190 feet tall total, 190 feet tall. Look at this 5.5 foot girl or 5.5 foot girl over here that's looking a 38 degree elevation from what would have been horizontal. And she's looking up, and when she does, she sees the top of the tower. I think I mentioned this to you, but I was taking a class 2 years ago in the summer, and we went out and measured the height of trees by doing this kind of thing. You can make relationships and know how these things connect together. So they want to know how far she is from the castle. That's what it says. How far is she from the castle to the nearest foot? They want to know how far this is. So they put a little X right here. Now, when we talk about this, we know that this is the angle we're discussing. We could discuss that angle because if that's 38, that's 52. Yeah, got that because we got it out to 90. But we're talking about this angle, and so this is the adjacent leg, and this is the opposite leg because that's the hypotenuse. We don't care about it, but it is. So that's tangent. Because we know that the tangent, when you're doing that, sine, cosine, tangent, orange horses always have orange ankles. So that's what that is, tangent. So we set this thing up, and you've got to start, you've got to do this. Listen, students always want shortcuts, they always want to, and it's dangerous. Now, some of these problems you can do, you can sort of shortcut, you can probably get by with it, but I'm telling you, you can't do them all that way. And the problem is, once you think you've got a routine and you know how it works, then you're not looking at the math, you're going to miss problems because there are two flavors here. Not two flavors as in sine or tangent or whatever, but two flavors of the way they set up. Promise you, this is how it's going to work. So we got to set this thing up. So we have the tangent of 38 degrees is equal to the opposite divided by the adjacent. Now the adjacent's the x. That's the one that we're looking for, right? Right? That's what we want to know is that. What's the opposite? Think about it. What's the length of this opposite side right here of this right triangle that we have with Leah and the castle and the top of the castle and all that? Well, how long is that right there? And if you said it's 184.5, you're right. Because the whole thing's 190. Because the brochure says that the castle's 190 feet tall. So the whole thing's 190. But you know, little Leah over there is 5.5 feet of that to her eyeball. So this line right here, which is not the ground, it's up at Leah's eye level, is 5.5 feet. So that leaves only 184.5 to be from here to here. So sneaky, sneaky. This is how you got to be, you know, on top of your game right here. So at this point, this is tough. I mean, this is real. At this point, I want to solve this equation. Well, I've got an equation with fractions. What do? Make the fractions disappear. When I first started teaching in Algebra 1 in Chapter 2, people looked at me like I had, you know, horns or something growing out of my head. Look, there's a reason why we do this. The reason why we talk about that stuff then, because we're applying it to it now. So we're going to multiply by the least common denominator. The only denominator is x. That may seem weird, but that's what we're doing. These x's cancel. Now we have x times the tangent of 38 is equal to 184.5. Well, remember, our goal here is to get x by itself. Is x by itself? No. So I want to move the tangent of 38. Now, earlier we did those inverse things, and we were just trying to get rid of cosine, or just trying to get rid of tangent. In this case, we're not trying to get rid of tangent. We're trying to get rid of a tangent of 38. So it's different. So we're going to divide both sides, because it's multiplication. We're going to divide both sides with a tangent of 38. So if you got that calculator on your screen somewhere, some instrument you have, then you're going to find out that x is equal. You just plug it in. Make sure you're in degree mode. Make sure you're in degree mode. So you're just going to plug it in. 184.5 divided by the tangent of 38, and you get the answer. So you can see they set this thing up. They did the 184. This is, like I said, it came out of the book. They did 184.5 because that's the thing we saw with little Leah. They ended up doing the same thing that we did. They got this. They put it in the calculator. They got that. So she's about 236 feet from the castle. We could do lots and lots of these problems. I will point out to you, here's that angle of depression and the angle of elevation being the same, because those are actually alternate tier angles. You've got the water level down here. You've got the chopper, you know, moving or hovering horizontally across the, or parallel to the water. And you got some person coming down here, and it's 18 feet to the water evidently, and you can see that they want to know how far it is to this person. That's the question. So if we're looking at this angle, this is the opposite side, this is the adjacent side, which means we'd be doing tangent again, and we'd set it up and work it the same way we did the one a few minutes ago. Let me go back. So that's where they would set it up, and you could find that out. But like I said, it's tangent because you can tell that it's tangent here because you have O and A. So you can tell what that is. So in that case, you just got to be paying attention. I mean, you got to know sine, cosine, tangent. It's not hard to know, but you have to think about that in every single problem. What function am I using? Why am I using that function? How's this going to work? So you got to take the time to plow through that. A lifeguard. I mean, this is all the same stuff. It's all the same stuff. They didn't close the end of their right triangle, but we presume that's how that's going to work. And the 8 degrees is this. That's the angle of depression. She could be looking straight out, but she had to look down 8 degrees to look at a swimmer person over here and make sure he's not getting in trouble and doing something he shouldn't out there, or getting pulled off into the ocean. It says the lifeguard is watching a beach from a line of sight of 6 feet above ground. So this is 6 here because she's 6 feet above ground, right? And so these two things are going to be the same, because you could actually make a rectangle out of this. She sees a swimmer. How far away from the tower is the swimmer? So you could look at that as X, you could look at that as X, it's the same. So if you're looking at that original triangle, we wouldn't think of it here, we think of it there. But you can see with this is opposite, and this is adjacent, so it'd be another tangent problem. So we'd set it up, and we'd do the work. Let me do that. Let me just do it. So the tangent of 8 is So you remember, orange words always have orange angles. So for us in this problem, the O is 6, and the A is X. So you multiply both sides by X. And then divide by the tangent of 8. And put it in a calculator. Okay. So a couple of problems here for us to look at. It says, in the circus, a person in the audience at ground level watches the high wire routine. A 5'6" person or tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees? We do word problems. Do not be afraid to read them 2 or 3 times. Picking up pieces here and there, you know, looking at data and information and analyzing what's being asked, what's being said, what's being asked. Don't be afraid to do that. Now, I've added this picture to this problem, and what I did was I went ahead and you know, did my right triangle, and I looked at this distance here to like a platform here, because it says the person is standing on a platform. This is a high wire act, you know, they're getting ready to walk on this wire out through here. And so when I look at this, this person is 5.5 feet tall. And the platform is 25 feet above the ground, or off the ground. So you can see this whole thing right here, like the whole thing, is going to be 30.5 feet. And that's some analytical things you need to bring to the table here to be able to understand this. Now, this person sitting down here is looking up, you know, oh, they're looking up at this person, and they're looking up at a angle of elevation of 27 degrees. 27 degrees. And so the question is, how far is the audience member from the base of the platform? So this is what we're looking for. How far away is the audience member from the base of the platform that the guy is standing on top of if he looks at the top of his head at a 27-degree angle? That's what we've got here. So when I begin to analyze, once I get everything labeled, I analyze what's going on here. This is my angle, this is the adjacent leg, this is the opposite side. I'm tangent again. Seems like a lot of these are tangent, and they really are. A lot of these ones in this material is tangent. So I'm going to do the tangent. Let me get out of my own way here. The tangent of 27 is equal to well, it's down there, you can't see it. It's orange ankles, right? So when I look at this, the opposite is 30.5, and the adjacent is the unknown x. So I'm going to multiply both sides by x, and then I'm going to divide by the tangent of 27, so that x is equal to 30.5 divided by the tangent of 27. Calculator in degree mode, tangent 27, sorry. Calculator in degree mode, punch the buttons, burp out an answer. Their picture's a little cuter than mine, but you see the audience member sitting down here looking up. They can look at the base of the platform where the feet of the performer is, or they can look at the head, but you can see the one to the head's what we're talking about as far as the angle of elevation. You can see the 25-foot tower with the 5.5-foot acrobat standing on top, and you can see the unknown x from the person to the base of the tower. So their drawing looks a lot like mine, only cuter. And they set it up, and they did the same things we did. And when they put this in the calculator, which is what we have, put this in the calculator, they got 59.9, and that would be feet, I believe. We're talking about how far this is, because this is feet, so this would be feet. So it's almost 60 feet away is where the person is sitting. That's what it says here, 60 feet. 59.9, so it's about 60 feet. So all these problems, there's like more problems, and there's more platforms and more things to discuss and more things to make connections for, and we could take the time to look at a lot of these. A problem like this, I don't have time here to do this problem, but I want to talk about it at least in part. It says Maria is at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression is 52 feet, what is the horizontal distance from the seal to the cliff to the nearest foot? So Maria is up here on top of this cliff, right? Maria's up here. And she looks down into the water and she sees a seal, or the seal down in the water. The cliff is 40 feet above the water. The angle of depression is 52. So that's this measure, right? Angle of depression. If that's 52, then that's 52 because those are alternate interior angles. So I'm actually going to be talking about this angle for my discussion. It says, what is the horizontal distance from the seal to the cliff? And so we're looking for this measure right here. If we're going to look for that measure right there, we have to analyze our picture and see what trig function are we going to use. Since this is our angle, then this is the opposite and this is the adjacent. I've said this already, but it seems like a lot of these are tangent, and they are. But not all of them. We can certainly do other ones, and we will see a couple of different ones, but a lot of them are tangent. So we're going to say the tangent of 52 is equal to, remember orange horses always have orange ankles. Tangent of 52, so when we do our orange, we get our opposite, we get the 40, and we do ankles, we do the adjacent, we have x, so we multiply both sides by x. And all these seem to be working the same way, but I'm telling you, there's another kind. So you got to set them up, take the time to do it, divide by the tangent so that you get the x by itself. So it's tangent of 52 is a denominator. Put it in the calculator and round to the nearest foot. Their picture's cuter than mine. All their pictures are cuter than mine, but I got the job done. You can see the angle of depression ended up being the same as the angle of elevation if the seal's looking back at her. And the 40-foot cliff and the horizontal distance. And so you can set that up. Let's see, here they did. And they got that, which led them to that, which is what we had. If we'd have put it in the calculator in degree mode, we would have found out 31.3. Remember, what we're asking ourselves is how far is it from the seal to the cliff, the horizontal distance. So it was 31.3 feet. So we're going to do that one, right? And I did it. So we could do more of these. They're all going to work similar, except for there's those few nuances that we can talk about. I just wanted to mention this one problem before we conclude this lesson. There's a lot of work here that we won't take the time to do. But I do want to at least take the time to talk about how clever this is. Now, I'm a cruiser person, and I've never looked out at dolphins and wondered how far away they were. I have seen some. I've never looked out and thought how far apart are they from each other. I've never looked out and thought about my angle of depression in my eyeball looking down at those dolphins in the water. But the idea of what's possible using math is pretty powerful. Vernon here is on the top deck of a cruise ship and observes two dolphins following each other directly away from the ship. Now the problem with this picture is the stupid dolphins seem to be going toward the ship. And this clearly says that they are following each other directly away. So, the picture to me does not really fit. But what I did was I took the two triangles. You can see there are two triangles. The one triangle is made looking at the lighter dolphin. The other triangle is looking at the darker dolphin. So I made two triangles with them, and I turned my dolphins around so that they're going away from the cruise ship, okay? So, my picture is better than theirs in this case. And so, since you're looking at this darker dolphin here, you can see the angle of depression to look down at it. He looks down, he sees this one. If he's going to see the other one, he has to look down a little further. So you can see why one of them's 35, one of them's 36. So this is the 35 degree. It would have been out here, which means the alternate interior is 35 there. So I'm just gonna mark that one out. And then this one would be 36 for the same reason. So you can see how that would work with the alternate interiors. Hopefully you see how that would work. This is 154 feet, no matter what, that's how far it is up to the upper deck of the cruise ship. According to our problems here and our picture here, that's how that would work. It says find the distance between the dolphins. Wow, how far apart are the dolphins? And this is where I'm not gonna do any more of the problem. It's gonna say what you would do. So I would let this be X to see how far it is from the ship to the darker gray dolphin. And I will let this be Y, so I find out how far it is from the ship to the lighter gray dolphin. And once I find out how far it is to the dark gray, and how far it is to the light gray, I subtract. Makes sense. But I actually am going to have to do two trig function equations.